So section 4-2 should already be labeled for you. It's called Angle Relationships in Triangles. Should be written on the little flap for you. And so we're going to talk about some theorems and some corollaries and some definitions. The first one is called the Triangle Sum Theorem. Go ahead and circle that word sum. What does the word sum mean? What? Add, right? That means we're going to add all of the angles inside the triangle. What should they add up to? 180. Okay, so you're going to draw a little triangle, label its vertices A, B, and C. This theorem says that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Box number 2 is called Corollary 4-2-2. So basically it's the 4th chapter, 2nd section, 2nd theorem or corollary. And it says that if you have a right triangle, so you're going to draw a triangle and put that little box in the corner. That means it's a right triangle. We'll call this triangle DEF. This would be the second box, the one that says Corollary 4-2-2. Okay? This theorem says that if you have a right triangle, the other two angles should add up to how many degrees? 90. So the measure of angle D plus the measure of angle E is equal to 90 degrees. Because this one's already 90, and 90 plus 90 is 180. Okay? The third box says Corollary 4-2-3. And it talks about an equilateral triangle. So you're going to draw a triangle with the three sides as close to the same length as you can. We're going to put 3 tick marks to show that it's equilateral. We'll call it triangle ABC. This corollary, like I told you yesterday, says that if it's an equilateral triangle, it's also a what kind of triangle? Well, it's acute, but it's also equiangular. So this angle, and this angle are all going to be how many degrees? So the measure of angle A is 60 degrees, the measure of angle B is 60 degrees, and the measure of angle C is 60 degrees. All right, so that's box 3. Now go down to the second row. We're going to go to box 4, and we're going to talk about exterior and interior angles. Okay, so we're going to draw a triangle, but then we're going to extend some of the sides. So this side right here, we're going to extend this way, and we'll label these angles 1, 2, and 3, and this angle will extend this way, bless you, and this angle will extend this way. And so what we're doing here is we're creating some interior angles and we're creating some exterior angles. Any of the 3 inside are all what? Interior. And anytime you create an extension and it creates an angle outside, we'll call those exterior. So here's an exterior angle, here's an exterior angle, bless you, and here's an exterior angle. All right, we good so far? All right, now we're going to move on to the next box. The next box says the remote interior angles theorem. Okay, so we're going to draw another triangle. We're going to draw a lot of triangles this chapter. And we're going to extend this bottom side out in this direction, which creates this angle outside. Is that an interior or exterior? Exterior. This is your exterior angle. Okay. The title of this theorem is called the remote interior angles theorem. So we want to say something about these interior angles that are remote. What does the word remote mean? What? No, not the same.
Like separate.
Separate, or what we call far away. So if this is the exterior angle and these are all interior angles, which two interior angles are far away? The two that are over here. So we'll number them 1 and 2. Okay, see how they're not right next to the one that's exterior? They're farther away. Think about you're sitting on the couch and your TV's over there. How are you going to change the channel? With a remote, right? So when I was little, we didn't have that. We actually had to get up, walk over, turn the dial on the box. Yeah, okay. But now you guys were born and you never probably had to ever do that. Did any of you ever have to do that? A couple of you? Like on an old TV? Maybe? Okay. All right. So here's what this theorem says. This theorem says that the exterior angle, so angle, the measure of angle 3, is going to be equal to the sum of those two remote interior angles. So it's going to be equal to the measure of angle 1 plus the measure of angle 2. Add those two together, that's going to be the same measure as that third angle, or that exterior angle. All right, I'm going to move this up. You'll see it in just a second. And we've got one more box to fill in before we do the examples. All right, that 6th box is called the third angles theorem. Okay, so for this one, we need to draw 2 triangles. So this first triangle is LMN. The second triangle is RST. And this theorem says that if angle R is congruent to angle L and angle S is congruent to angle M, then something special is going to happen. So we'll put a dot, dot, dot. Okay? So let's mark the information they gave us and see if we can figure out what that third thing is. Okay? So the first thing is R is congruent to L. So we're going to find R over here, and we're going to put a little arc, and then we're going to find L over here, and we're going to put a little arc. So those two angles are congruent to each other. Okay? And angle S is congruent to angle M. So here's S and here's M. So we're going to put a double arc. Okay? So these two angles are congruent, and these two angles are congruent. What do you think the third angles theorem is going to say? That the third ones are congruent. That's why it's called the third angles theorem. So we're going to say that angle T is congruent to angle N. Okay? Any questions on that last theorem? All right, let's look at some examples. All right, for example 1, we're going to have a drawing. Move that up a little bit for you. There we go. one, let me give you some measurements. This angle is 12 degrees. This one is 62 degrees. This one is 40 degrees. All right, so we've got a triangle with two triangles inside of it. We saw this yesterday. There's actually three triangles there. Everybody see three triangles? Okay. No? All right. So the directions for part A say find the measure of angle XYZ. So you're going to take your finger or your pencil and you're going to tap it out. Here's X, here's Y, here's Z. So they want this angle right in here. I'm going to put a question mark, or you could put X. Whatever works, okay? So this angle right here is part of this triangle inside that's on the right, okay? We learned the first box was what? Triangle Sum Theorem. All the angles should add up to 180. So if we know these two, we're going to add them together, or you can start with 180, subtract the 62, subtract the 40. What are you left with? 78. Okay? Any questions on part A? All right. Part B. Now we're going to find the measure of angle YWX. All right, so if we come up here and we tap out YWX, so here's YWX, that's this angle right here, so I'm going to put another question mark right there. But when we got this one as 78, what do you notice about these two angles right here? They equal 90. So what kind of triangle is this? It's a right triangle. So if you look at the second box, the one that says 4-2-2, what does it say about the other two angles in a right triangle? They should add up to 90. So if you look at the right triangle, and here's the right angle right here, that means that this angle and this angle should add up to 90, right? So we're going to say 40 degrees plus X, or question mark, whatever you want to call it. We'll change it. Let's change it to X. Should be equal to 90. So what's that measure? 50. So we got a 50-degreeer in there, okay? All right, any questions